See what this delay looks like.
So yeah, see if we get some sort of crazy feedback loop.
You should. It should be broadcasting now. You're not getting it, huh?
Yes.
There we go. You should. It should be broadcasting now. Can you turn your audio off? You're not getting it, huh? There we go. You should. It should be broadcasting now. Turn your audio off. You're not getting it, huh? There we go. You should.
It's weird. Why is it still going? Sorry, yes.
That was quite a delay. I don't know how that's going to work out. We'll see. I might just have to head over there and plug in myself and talk from over there, I guess.
What's the screen delay is really bad?
Yeah. Because I scrolled down already. Yeah. That's okay. Move over here. It'll work. I'm a loud person. Yeah. Let's plug in myself. Fine. All right, let's see if this works. How far can this go? Not very far. There we go. Okay, I'll just have to talk loud today. How's everyone doing? Doing well? All right. Anybody? Cool.
From an incredible angle.
Got it. Everybody see the summary of the class and the video and everything that was posted on Slack? Is everyone in the Slack channel? If you're not, if you're on the Slack, the Code the Dream Slack, the channel is JS-Basics. And that's where I'll be posting links to the classes, to the live stream when we're streaming, lesson plans, and any homework that we have after class as well. So I've already posted stuff from the first class, which is basically just a summary of the class. And then there was sort of an optional homework if you really wanted to work on your command line skills a little more. So I think the first thing I wanted to do is just spend a little time reviewing the command line, making sure everyone felt comfortable with it. Did anybody have anybody play around more on the command line after class? Yeah, a few people. All right. Do you feel comfortable? Did you have any problems with it? Any challenges you encountered? You got out of your directory and took a little bit to get back? Yeah. That's one of the most basic skills, is learning how to navigate your directories at the command line. And it takes a little bit of practice to get into the groove of how to do that. But eventually, you know, some developers, it depends on the developer, actually prefer operating from the command line in a lot of cases as opposed to from a graphical user interface. They just find it's faster, or they don't have as much going on, so they can focus a little more easily on their work. But the essentials of it are a skill pretty much everyone should pick up, because if you're going to be doing software development, you will have to operate at the command line at some level. Whether you're doing Windows development or Linux development or JavaScript or other programming languages, there's some command line work that you'll end up doing. Does anybody have any general questions? Yes. You weren't able to write into the files. Yeah. Okay, were you working on Cloud 9? Yeah. Okay, and did it give you like an error message when you tried to write the files? It was just frozen? All right, if you want to, we can follow up with that like after class, because this class probably, I'm still very intro, and so I don't know if we'll go the full time. There'll probably be a little time either after, or maybe we'll take a break in the middle and I can come over and work with you on that and see if we can work through that problem. Anybody else have any questions or any challenges that they encountered so far? No? All right then. I think it's sort of getting you guys talking, having a conversation here. The first thing I wanted to do, we looked at some of the command line stuff. These sort of precursors to learning how to program, the skill set that you need to be successful at coding. But let's just have a conversation of what you think of programming. Like, what do you think of when you think of programming right now? Anybody have any ideas? What comes to mind? Creating a graphic user interface? Yeah, that's great. Yeah? Solving problems. All right, I like that description. That tends to be close to what I have. I don't know if anybody saw my comical shirt my wife got me, but it says a programmer is someone who solves a problem you didn't know you had in a way you don't understand. Anybody else? Any thoughts or ideas? Just what comes up when you think of programming? Nobody thinks hard, like difficult, challenging, scary. I know that's a lot of stuff I had when I was learning how to program originally. I thought it was scary, intimidating, just so much. Like, I can never understand this. I thought it was magic. Like, it's like, what is this magic going on? I don't understand. Especially when I started learning the basics of programming, because I started like you guys will learn at sort of the command line, doing these very basic programs. And I'm thinking, I spent a whole like semester or year learning how to just write these tiny command line programs. How am I ever going to write something as complex as a graphical user interface and these other complex behaviors? There's no way I'm going to get to that level. Any other thoughts about programming? Anything that comes to mind? Repetitive? Nice, I like that. Yeah. Challenge. There you go. I think to me that sort of goes together with like solving problems, right? Like a problem is usually something that's challenging in some way, and programming is challenging because you're trying to solve problems of some kind. All right. I think those are all great thoughts around just programming in general, right? I think it's a very broad topic, a very broad field, but the best description I heard, is just it's solving problems. So programming is helping us solve problems, and computers from the very beginning, what we've been using them for is to solve problems more quickly than we could solve them without them, right? Like the first computers we had were just there to do computations of math, of trajectories, of paths of motion and things like that, because those are very complex mathematical problems to calculate. And if you have a computer that can do those steps at thousands of computations a second, or nowadays millions or billions of computations a second, that's a lot faster than you or I are going to be able to do those computations. So really all a computer is doing is speeding up problem solving for us. And programming is just how you tell the computer what problems you want it to solve. It's just a way to tell the computer, here are the problem I'm trying to solve, and here's the constraints around it. Why don't you go ahead and solve it for me? Does that make sense? Yeah? So in class today, we're going to go over a few different major areas. The first section will be just an introduction to programming languages in general, the concepts, the high-level ideas of how they work, and a little bit of how computers work. You may have already run across this in other classes or other places, but we'll go over it again. And then we'll get to talking more about JavaScript in general, which is the language we're going to be learning in our class. And along with that, we'll go into some details of JavaScript and start learning some very basic elements of how to write a JavaScript program. You're not going to walk out of here today with a huge tool set of things that you have to learn, but you'll get the basics of the language. And then I'll also be giving some assignments, especially for these first several classes. A lot of the assignments are going to be very much repetition type assignments of a lot of do this same thing over and over again, just to sort of get you into the mindset, get you into practice of typing this stuff out. Because before you can really begin to understand how it works or all the underlying pieces, you just need to get comfortable with typing in that language, even if you don't fully understand it all. And that's what we'll have. I'll be sending that out after class, some assignments around some of that. So let's start off with sort of an intro to programming in general. And I'm cribbing these slides from somebody who works at Khan Academy, which is a great site to learn anything. They also have great programming tutorials on there if people are interested in that. But it's a little bit of the question of like, what is programming? And I think I tried to answer that a little bit before. That's solving problems in some way. But what does it mean on the computer? Like, how does the computer work? How does it solve these problems? What are you doing when you program? And when we talk about programming for a computer, there's really three different sort of levels of code. Because a computer, and we've got them all sort of here, we've got these high-level languages, assembly language, and machine code. The computer at its core, the processor, the fundamental pieces of it really only understand machine code. And machine code is that scary ones and zeros that we've all seen, right? The computer only stands this binary language of a series of ones and zeros that tell it specific commands to operate on. So in this case, like this series of ones and zeros is saying, load the first operand into AC. That's very confusing. Even with the comment, I don't understand what that means. It's all very low level of the way that a computer works and the pieces and the interactions that it has. And so you can imagine why I program professionally every day, and I have no idea what this, I would never be able to read this machine code, and it's specific to every individual processor or program. So the processor in my Mac uses different machine code than the processor in my phone. So I wouldn't be able to even write the same code into each one of these things and have it run, which means that if we were to try and write stuff at the machine code level, first off, it would be incredibly hard. Only the most gifted people would ever be able to produce the output that you need for it. It would take a very long time to write all these sorts of ones and zeros, and you would have to rewrite it for every platform that you worked on. Did you have a?
Yeah, I was going to say, you mentioned that you use machine code for your phone. Are different. I wanted to know, like, you say different, they are different. But they by extending
What was that? The last bit? Sorry.
you say that the machine code running into your phone and the machine code running into your Mac.
Yeah. Yeah, the machine code is different from my phone.
How are they different? Are they like binary?
Yeah, there'll be different binaries, different items entirely. In say, it's a little hard to. I wish I had better visual graphics, but the processor, the core thing that is running that machine code, they're not all the exact same processor, and they're built different. So one of them may have, for example, 3 places to store data on it. So it has 3 little places to put information, and you can work with those and put stuff on it and do computations with those 3 storage locations. Whereas the one on my Mac, I mean, maybe it has 20 storage locations. And maybe the one on my phone can only store very specific things in each one of those locations to do the computations. But my Mac, you can put a lot more in those different locations. So since that's the way that processors work and they're built differently, each one of those has to have, if you look at these instructions, right, this load into AC or add second operand to AC, those are instructions that are specific to that processor or that processor type. So like an Intel processor, most of those are going to be very, very similar, and you're going to be able to run the same low-level commands. But there's other processors like PowerPC or different processors that exist, or most phones use something called an ARM processor. And those have an entirely different set of commands. So they may not have a load operand into AC. They may have load something into EAX, which is a unique thing on that processor. And since they're different between them, you can't use that exact same machine code on them, which means that if you were to actually try and write for each one of those, you would have to rewrite your program at that machine code level on each one of those platforms, which obviously doesn't scale. And obviously writing in these sorts of ones and zeros doesn't work effectively either. And that's why early on, well, even the ones and zeros, those didn't last long at all as a programming concept. So very quickly, they moved up to this concept of an assembly language. And an assembly language is a little easier to read. If you look at the instruction code column here, that's a little bit easier to read than, say, these zeros and ones. You can imagine if you spent a lot of time working with these commands, this org 100 or LDAA, that you might eventually be able to learn what those mean. But this is still just one level above, and assembly languages are tied to not necessarily each individual processor in the same way as machine code would be, but to a processor family, like I talked about with ARM processors versus the Intel processors in most computers. Assembly language is specific to that processor family because they know how to take this assembly language, and this is something that's about as low level as any programmer would ever write. But the programmer, or there's code down there on each processor essentially to take this assembly language itself and turn it into that machine language that you actually run on the processor. But another problem with this, still very unreadable, still very hard to do anything. And all of these instructions, if you look at all of this here, the only thing this did was add 2 numbers. So every one of those instructions together, and I think it's the same on this page too, the only thing this did was take 2 numbers and add them together. That's a lot of code to write, to say add 2 numbers. And it would be unique to each processor or processor family. So again, you have to rewrite it for different platforms. And that's where the concept of a high-level language comes in. A high-level language solves a lot of these problems for us. High-level language is both much more readable. So here's a program that does sort of the same thing, and this is in Java, but JavaScript is very similar, that adds some numbers together. And I would say, I think, do most people feel comfortable looking at that? They don't feel like it's too hard to understand. There's some stuff that's not completely clear, but you feel like you can get a grasp on that. Much easier than, say, this assembly language, which would take a very long time to get a grasp on. And the other huge benefit that you get from this is not only being able to write and read and understand it much more easily, but this same program, this same high-level language can run on any processor. And the way that we do that is through compiling or interpreting for that individual processor. So what we've built for these high-level languages is we sort of have two different paths for how you get this high-level language, Java, JavaScript, something, into the machine code for your actual processor that you're on. So the first thing that you're going to do if you're a compiled language like Java is you're going to compile your code. It's going to take that Java and run it through a compiler, and that compiler is actually going to output assembly language. It says machine code here, but you really get assembly language code essentially out of that. And then the processor itself, or lower level, is able to handle that assembly language conversion to the machine code for what you need on the actual processor. But by doing that, you can recompile this same code on the ARM processor in my phone, or the Intel processor in my computer, and have it run on each platform, but you didn't have to rewrite your code. So that's what you get when you're working at these higher level languages. You get something that's much easier to read, much easier to understand, and you can easily port it from platform to platform. And compiled languages are probably the most common one. They've been around, I would say, longer than interpreted. And the difference between these two is when you compile it, you take this entire program, every line of it, and write it out or compile it into this machine code all at once. So you take all of it and out comes sort of this machine code for your platform. And by doing that, you get some benefits. It's able to look at all these different lines and maybe optimize things. This compiler program, which are some of the most complex programs that exist, but it can look at all this and, oh, okay, maybe I can simplify this in certain ways and make it easier or map it to faster operations on our platform. The alternative to compiling is interpreting. And that's what languages like JavaScript or Ruby or other, you'll hear them called either interpreted languages or scripted languages a lot of times. That's usually the way that they operate. And the difference there is instead of going straight to machine code, they're interpreted into like this sort of virtual machine or language that knows how to interpret its stuff into machine code on the fly. So instead of, for example, this Java where this whole thing is compiled and put out at one time, an interpreted language is run sort of line by line. So this first line would be interpreted and written into machine code. And then the next line would be turned into machine code. And the third line would be turned into machine code step by step. And there's different trade-offs that you get using an interpreted versus a compiled language. A compiled language can be optimized more easily for the platform, so it's a little better in that regard. And since you're already in machine code when you're running it on the platform, it should run faster because the interpreted language is having to convert to machine code line by line as it runs through the code. However, one of the big benefits that we get, and why I love teaching with interpreted languages as opposed to compiled languages, is that with an interpreted language, you can see what's going on with your code line by line as you write the code. So instead of having to write an entire program and all of the lines of code and then compile it and see if it runs, with an interpreted language like JavaScript, if we are working in JavaScript here, and let's just open up a JavaScript space. So this is an interpreter for JavaScript. I can do 5 + 5 and see the results immediately for that. Whereas if this was a compiled language, I would have to, if that was just part of my program, I would have to have all of the bits and pieces of that program written, compile it, and see what happened all at one time. So in interpreted language, one of the big benefits is that immediate feedback. You get to see the results of each line while you're working in it, and you really get a fast iterative loop of sort of learning. And that's one of the huge benefits that you get working in one of those languages, especially when you're first learning how to code. I'm gonna pause and take a break right now. Are there any questions right now? Just programming languages in general. compiled versus interpreted languages. Yes.
Is any specific like limit to, you know, to, let's say we had a problem that we have to solve, we have to write code. Any specific limit that we make, say never that problem
Right.
so they all do the same thing, you know, solve any problem.
Let me both repeat it for the video, but also to make sure I understood. Basically, you asked, are there certain problems that can only be solved with a compiled language or an interpreted language versus the other one? And no.
Yeah, I was gonna say, like, I heard that sometimes there's applications that are so loud, so complex that just can be approached language, Java, or C++.
Sure.
So I'm not sure if the same problem can be brought into problem. I mean, a language like definitely JavaScript.
Right. Yeah, and I would say there's sort of two answers to the question of can they be written in any language. The basic answer is yes. So any programming language, I'm going to give you some sort of deep theory of computer science for a split second. But there's a concept known as a Turing machine. So one of the early computer scientists, one of the first guys who created this field was Alan Turing. And he's more famous for his Turing test, which is a test for artificial intelligence. But in terms of the fundamentals of computer science, he created some very strong underpinnings for it. And one of the things that he stated was a concept of a Turing machine. And a Turing machine is a very, very low-level concept. I'm not going to go into all of the details, but it's literally just that. And there was no computer that did this at the time. This was just him theoretically talking about what a computer could do. And he was trying to build almost the most minimal programming language, which was essentially a tape. Just like if people have had cassette tapes or VHS tape or anything, that just had like ones and zeros more or less on it. And every instruction on that tape either just moved that tape forward or moved it back to another one. And he was able to prove that with this very, very minimal programming language idea, that you could compute anything that could be computed, that you would be able to solve any problem that could be solved with a programming language with that, essentially. And so there's a concept in programming that basically says if a language is Turing complete, which pretty much every programming language you would encounter is, it can solve any problem that can be solved with any other programming language. It's possible for them to solve it. There are some things that you'll encounter that might be called a quote-unquote language that can't do that. Like HTML is not a real programming language and can't solve problems. And because it doesn't really have these core fundamental pieces of a programming language. But pretty much any other programming language, compiled, interpreted, it doesn't matter, can solve any problems that you're going to encounter. Now, to go with that, though, the other side of that was I was talking about the pros and cons of compiled versus interpreted. And there are definitely problems that are much better to solve using, say, a compiled language because you're going to get more performance out of it in general. Because it pre-compiles it. It can optimize this entire program at once and do a lot of complex optimization that you can't do when you're reading something line by line. It's a little bit like if somebody asks you to read out loud in class and you've never read it before. You're going to go a little more slowly. It's hard. You get hung up on words or other things that if you've already read through it, you're probably just going to fly through because you've been able to put together, oh, this is how that sentence really works. And that's sort of the pros and cons of compiled versus interpreted. So yes, there are problems that you probably wouldn't solve with an interpreted language because you need really high performance. And if you really need the highest of performance, sometimes you even go down into assembly language for the platform that you're on, because you can do very, very specific coding yourself to optimize certain things. But in general, like the general answer of can they do any computation? Yeah, they can solve any problem that another language can solve. Any other questions right now? All right. Then we're going to talk a little bit about the different JavaScript interpreters that you can use for this class. And then after that, I think we'll take a short break and you can come back. So JavaScript, which is the language that we're going to be learning, is probably the most universal programming language in the world. And that's because it's the language that runs in your web browser to give you interactivity. So these slides that I'm presenting here, they're using JavaScript to handle the transitions and how they work. And since that's the case, that means that your browser already has the capability to understand JavaScript, which is awesome. That means every one of you has on your computer with any web browser the capability to run JavaScript code and see the results. And we'll look at that in just a second. I wanted to show first the Cloud9. So everyone's got their Cloud9 environment set up, is that correct? Everyone have their Cloud9 environment set up? No, but does anybody not have it set up yet? Let's ask it the other way. Okay, great. So in Cloud9, you'll have your terminal at the bottom of your Cloud9 space. I've expanded it so it takes up pretty much the whole window here, but you've got your terminal space right down here. And when you're working in your terminal, you have a JavaScript interpreter that you can invoke just by typing the command node. So if you type node in the Cloud9 terminal, you'll notice that this terminal prompt changed. We no longer have this nice CTD instructor workspace thing. We just have a little arrow. And that's because we're actually running inside of another program right now. And that program's waiting for us to put something in for it to interpret. It's just sitting there saying, all right, I'm waiting for you. Give me something to interpret. And the way that we do that is we just type something and then hit enter. So you can type 5 and hit enter. And it'll go ahead and interpret that result and then spit out what comes back from it in a sense. So it just says, oh, I got 5 back out of this line. So this is the first way that you can access a JavaScript interpreter. You use 5 plus 5. And you can do 3.14 times 5. So when you're working in class, you're going to be using this node interpreter a lot. And I suggest you get relatively comfortable with it. Yeah, I think you definitely will be by the time we're done, but get some experience with it. One thing that you'll notice was I even had trouble getting out of it when I was in it just a moment ago. So you can do like Control-C to exit out of it. But you can also see that it says if you type .exit, that also gets you back out of it into your standard terminal prompt, and you can do your other terminal commands in there. Also, when you're in this node environment, all your terminal commands that you're used to don't work because it doesn't have access to like ls. That's a command that exists at the terminal level and not inside of Node. It doesn't know what that command is. It only knows how to interpret JavaScript that it's been told to run. So you'll definitely at some point make the mistake of, oh, I'm in the Node console and I'm trying to do a change directory. It's not working. So just exit out, Control-C a couple times to get out of there, or .exit, and then you can type those commands and go back into Node. That's the first one that you'll have access to, but sometimes, I don't know, maybe sometimes you won't be on your Cloud9 workspace. You won't have access to it. It might just be a lot to spin up Cloud9 or log into it to get access to something. And this is where having access to a web browser or using JavaScript is such a benefit. Because if you're using Chrome, who uses Chrome as their web browser here? Yeah, most people. So I expect if you're using something else, you also have access to it, but Chrome is perhaps the easiest. So Chrome, on a Windows computer, F12 is the easiest way to bring this up. On a Mac, I can never remember the exact command, so I usually have to come over here. Looks like it's Command, Option, I, or you can also just click it from this More Tools, but you want to bring up your developer tools. So if we do Command, Option, I, you can see I brought up these developer tools here, and there's a lot going on in here. There's got memory and elements and network and all this stuff. And you don't really need to worry about most of those right now. Just click on the console tab on the top. So if you click on console inside of your developer tools, you should see something that looks a lot like that node environment that we were just in. We've got a little arrow and a prompt, and it looks like we might be able to put something in there. So sure enough, it looks like it works just like that node environment, where we can just go ahead and type some JavaScript and see what the results are. Now it's a little different because there's no full terminal behind it. So if you want to clear it, there's a little clear option up here to clear output so that you're not cluttered up. And there's a whole bunch of other options and information going on here. But it's a very awesome tool that's right there at your fingertips inside of every browser that you're in. So if you ever want to just try out a bit of JavaScript, basic JavaScript, something simple, you have access to this console right here to try something out and can give it a go. That's one of the biggest benefits of JavaScript in general is everybody has access to something. You don't have to set up a special environment to have access to a JavaScript space and be able to work with it. Oh man, I can never remember the all right. Oh, it opened another one. I'm gonna have to learn how to get out of this more easily. I want my console drawer. I want to exit out of my dev tools. Now you get to see me get stuck. Oh yeah, that's right. Here we go. Exit full screen. Yeah, I did something really weird there, which you guys don't necessarily need to know about, but all those developer tools that are inside of Chrome that I showed when I went, did this, these are also all just a JavaScript application, a web application. So I opened up developer tools on my developer tools. Are there any questions about the different interpreter options you have, or how to get access to them and run some JavaScript code? All right, we'll take a short break if anyone wants to use the restroom or go and try and help out with this file copy stuff for a moment. And then we'll come back and we'll continue with the basics of JavaScript. We'll learn how to work with variables, the different types that exist at a most basic level, and sort of show some of that, and then we'll be done for the day. Oh, I hope it was screen sharing that whole time. Otherwise, people watching the video are going to be doomed.